Equilibrium state of dynamic balance part 3. With this segment we'll look at some calculations involving KEQ, determining KEQ values and also equilibrium concentration values. So we'll do two examples here in this segment just to make it relatively easy here. So given there's the equation for the formation of ammonia, nitrogen gas plus 3 hydrogen gas molecules in equilibrium with 2 ammonia molecules. Determine the value of KEQ given the equilibrium values at a certain temperature. So at a certain temperature, of course, varying temperatures, you get different results, but we'll just assume this is at some specific value. We have nitrogen at equilibrium being 0.533, H2 being 1.600, and NH3 being 0.933 moles per liter. So fairly easy. This is a fairly easy question. Just simply determine the KEQ equation. So of course it's products over reactants, NH3L squared over N2 and over H2 all cubed. Easy enough. And then simply substitute the values in. So we have our NH3 value, our N2 value, and our H2 value over there. So you can see it right there. And working it out, we get it to be 0.399. You should try to work that through your calculator and make sure you get that to avoid any mishaps. A couple things to note. KEQ, we won't worry about putting a unit on there because the units are dependent upon how many products we have, how many reactants we have. So don't worry about a unit per se. And also, by looking at that number, I can see that that number is in between 0 and 1. So KEQ is in between 0 and 1, therefore our denominator must be bigger than the numerator, reactants bigger than products, so we say reactants are favored over products. So we can get all that information from solving for KEQ. Second example I want to do deals with something different, looking for giving you the KEQ value and you figuring out one of the equilibrium concentrations. So at a certain temperature, the KEQ is known to be, for this reaction, 2.27 times 10 to the minus 3. So a really small number there, decimal 0.00227. So you can see that reactants are favored in this one because that's such a small value. And here's the equation. It's for this reaction, 2H2S in equilibrium with 2H2 and S2. And giving you the following information. Determine the unknown concentration given the following. So if I give you this, the unknown is figure out the equilibrium concentration of H2. Given that H2S is 0.184, S2 is 0.050, determine H2. And also giving you the KEQ. So we start this question off the same way. Find the KEQ equation first of all. So products over reactants again, H2 squared times S2 all over H2S all squared. So there it is right there. You may have noticed I put the H2 concentration in red because that's my unknown. So I'm going to have to rearrange the equation to solve for that. Now you can do it in a variety of different ways. You can substitute the numbers in and rearrange for H2, or I can rearrange the equation right now and then substitute the numbers in. So to do that you kind of have to, and this is the most complicated part of this question, just rearranging. Undo what has been done, so to speak. So we have H2 multiplied by S2 divided by H2S squared. So to undo the divided by H2S squared, multiply by H2S squared. And you have to think of this equation like a seesaw. What you do to one side, you have to do to the other to make it balanced. So if I'm multiplying that by H2S, I have to multiply that by H2S. And you can see I crossed it off because H2S squared divided by H2S squared is 1. So when I do that, I end up with, that is the equation. H2S squared multiplied by KEQ excuse me, equals H2S squared times S2. So next that I have to do here is, this is multiply, so to undo multiply, divide. I'm just going to grab some water here. So divide by H2S, or sorry, divide by S2, What you do to one side, you have to do to the other. Crosses off. And I'm left with that. I'm just going to erase this here for a second. That's going to come back. So I would get h2 squared is equal to all of this. Now what I did in the next step here is I just kind of flip this so the unknown is on the left hand side. We usually like to work left to right. So if I look here, I have h2 squared equals all of that. Now of course I don't want h2 squared, I want h2. So you would have saw that I had here, it's very similar to this. How do I solve for x in this case? And you may recall from math, take the square root of each side, and x would equal the square root of 9, which is 3. Technically it's plus or minus 3, but we'll just worry about the principal root, or the positive root. So I'll do the same thing here on this, with this equation. So I have that, and I'll take the square root of each side, and that the square root of h2 is simply, sorry, the square root of h2 squared is simply h2, and equals that. So that's the tough part of this whole question, just getting that variable isolated. And then substituting the values in from the original question. 0.184 squared multiplied by 2.27 times 10 to the minus 3 divided by decimal 0.54. Then I'm going to square root all of that once I calculate it. And when you do that, you get decimal 0.377. Have to have a unit here because it's concentration. Molar or moles per liter will work there. So run through this on your calculator. Make sure you get that answer. So solving for the concentration involves a little bit of manipulation, but you can definitely do it.